This first video is a crucial roadmap, summarizing the complete syllabus for our first unit. Unit I, Internet of Things, IoT. I hope you will understand this video. Rest of this video will continue by my virtual assistant, Nalini.
So you've probably heard this term thrown around a lot, the Internet of Things, or IoT. It's this promise of a world where everything around us is smart, responsive, and connected. But what does that actually mean for us? Let's break it down. I mean, really think about it. What if your coffee maker just knew when you woke up and started brewing? Or what if the heavy machinery in a factory could tell you it needed a new part before it broke down? This is the world we're talking about, one where every object has a bit of intelligence, and it's the core idea behind the Internet of Things. So, what is IoT really? At its heart, it's a network. But we're not just talking about your laptop or your phone. We're talking about connecting everyday physical things, your thermostat, your car, even a shipping container. We're basically giving these objects digital senses and a voice, letting them talk to each other and to us all over the internet. And the vision here, it is massive. This isn't just about a few cool gadgets. The goal is to build this huge, globally connected ecosystem. We're talking about completely transforming how our industries work, how our homes feel, and how our cities run. Everything from traffic to the power grid, all thanks to automation and real-time data. Okay, that all sounds pretty amazing, right? But how does it actually work? I mean, how does a piece of information from some tiny sensor out in a field actually make it to an app on your screen? Let's follow that data on its journey. The easiest way to get it is to think of it as a journey with 5 main stops. It all starts at the perception layer. These are the sensors, the system's eyes and ears grabbing raw data from the world. Then the network layer acts like a messenger service, just zipping that data along. After that, it hits the middleware layer. This is like the central brain in the cloud, where all the raw data gets processed and turned into something useful. What we usually see is the application layer, the dashboard or app on our phone. And finally, you've got the business layer. This is where the magic happens, where a decision gets made, like automatically turning down the heat or ordering a new part for a machine. Now, you might have heard another term, M2M, which stands for machine to machine. So what's the difference? Well, M2M is kind of the foundation. It's like one vending machine sending a direct, simple message to a server saying, "Hey, I'm out of soda." It's a point-to-point chat. IoT takes that simple conversation and moves it up into the cloud, where you can add powerful analytics and connect it to a whole ecosystem of other apps and devices. So it's not just one machine talking, it's all the machines collaborating. So what are the actual bits and pieces of technology that make all of this happen? Let's pop open the hood and look at the IoT toolkit. Okay, first up, you've got the hardware. These are the physical things you can actually touch. You've got sensors that collect data and actuators that do stuff. Think of these as the senses and muscles of the whole system. Then you have these tiny little computers called microcontrollers, stuff like an Arduino, which act as the device's local brain. And often, you'll have a gateway, maybe something like a Raspberry Pi, that acts as the bridge connecting all our local devices to the big, wide internet. All right, so how do all these things talk to each other? Well, you have to pick the right messenger for the job. For short distances, like inside your house, they use things we're all familiar with, like Wi-Fi or Bluetooth. But to send just a tiny piece of data across, say, an entire farm, they use special long-range, low-power networks. And for things that need to be connected all the time, like a self-driving car, they use cellular networks like 5G. And all these devices speak in these super efficient data languages or protocols just to save battery life and keep things running smoothly. And finally, we get to the software. This is the real brains of the whole operation. All that data from all those sensors flows into these incredibly powerful cloud platforms from companies like Amazon or Google. And there, data analytics and AI dig through it all, looking for patterns and making smart predictions. But with all this information flying around, security is, and I can't stress this enough, absolutely critical. That's why strong encryption is baked into every single layer, to keep the data and the devices safe from bad actors. So we have the hardware senses, the communication messengers, and the software brains. But what does all of that tech actually do for us? Let's take a look at where IoT is already changing our world, and we'll start right inside our own homes. The most familiar place for most of us is right at home. You've probably seen a smart thermostat that learns your schedule to save energy, or smart lights you can control from your phone anywhere in the world. And these aren't just neat tricks. They're systems that make our homes genuinely more efficient and responsive to how we live. Now, in healthcare, IoT is a total game changer. Wearables that track our heart rate or sleep or activity, they provide this constant stream of personal health data. This not only helps us with our fitness goals, but it also lets doctors monitor patients from afar, potentially catching serious issues before they become emergencies. Now let's zoom out from our bodies to our cities. IoT is making them way smarter. We're talking about streetlights with sensors that can dim when nobody's around, saving a massive amount of electricity. Or traffic sensors that analyze congestion in real time to adjust the timing of traffic lights, keeping everybody moving just a little bit smoother. And in the industrial world, the impact is enormous. Putting sensors on factory machinery to monitor things like vibration or temperature allows a system to predict a failure before it happens. It's called predictive maintenance, and it literally saves companies millions of dollars in costly downtime by fixing problems before they even start. And get this, it's not just in shiny clean factories. Even farming is getting a huge high-tech upgrade. You've got sensors buried in the soil that measure moisture levels, which then automatically turn on irrigation systems only when and where they're needed. It's called precision agriculture, and it helps us conserve precious water while getting more out of our crops. Now, connecting billions upon billions of devices sounds incredible, right? But it's not exactly a walk in the park. There are some really serious hurdles we have to get over to make this fully connected world a safe and effective reality. And these challenges are all tangled up with each other. Security and privacy are, of course, the big ones. Every single connected device is another potential door for hackers. Then there's just the sheer challenge of scalability. Managing billions of devices is a whole different ballgame than managing millions. We also need interoperability, basically a common language, so your smart speaker from one company can actually talk to your smart lights from another. And finally, of course, there's cost. For this to really take off everywhere, it has to be affordable. And this all brings us to the central, really important question. The Internet of Things offers us incredible convenience, no doubt about it. But as we weave this technology deeper and deeper into our lives, our homes, our cities, we are handing over more of our data and more of our control. So the question we really have to ask ourselves is this: how are we going to balance the amazing convenience we gain with the control we might be giving up? It's something to think about. Thanks for tuning in.